Hello guys, welcome back. In this video, let us understood how to implement or how to create a ML model by using neural networks. Till now, what we have seen? We have seen how to create regression based models or else classification based models directly by using ML algorithms. Now, in this video, we will understood what is the difference between normal ML models and ML models that are created by neural networks. So let's first understood how the normal neural network models are created. Now let us observe how linear regression model we created. For creating a linear regression based model directly only ML model without neural networks, we just imported that method from sklearn.linear models. We imported this linear regression and we just created our model. Similarly, for logistic regression, this linear regression model we use it for regression based tasks. For classification based tasks, we created logistic regression. That also we imported from sklearn.linear model and we created our model. Whereas if you see for text classification using Navy Bayes method, there also multinomial NB method we imported from sklearn.Navy Bayes method. By using that way, we created again our model by using a pipeline. So these are the ways that we used while creating our ML based model. Here we are using only sklearn, right? Yes. So while creating ML model, only ML model without using neural networks, we are using only sklearn library. But now what is our agenda or what we are expecting to do? We are expecting to create a ML model by using neural networks. We already know that deep learning models or neural network based models or ML based models. These are constructed by using neurons. You can see each ball here represents a neuron. By using these neurons, these are created by connecting them through layers, by connecting them through these connections, right? Yes. Here we have three layers mainly. First one is input and last one is the output and middle one is the hidden. Here this input layer is nothing but passive layer. That means it does not perform any task, it just takes the input. Whereas these hidden layer as well as this output layer are active layers. Nothing but here our main task will be performed. Like if you are expecting to, if you are using this ML based model that you are creating with the neural networks, if you are expecting to use this model for text classification or regression, then that classification or regression logic you need to implement at this output layer. Whereas in this hidden layers, in order to reduce the complexity or in order to perform the task fastly in the output layer, you will introduce few things on your input data. Nothing but you can assume like you are introducing non-linearity on your data. So now we know how the neural network looks like or ML based neural network will look like. Now we also know it contain majorly three layers: input layer, hidden layer and output layer. Input layer must be a single layer, output layer must be a single layer, but hidden layers may be multiple layers, right? Yes. Now let us understood how to implement this, how to build a model with these layers. Now we need to build the ML model with neural network. So till now, you have seen ML models that you created without a neural network. Those are imported from sklearn. But now, in this case, since you are building your ML model with a neural network, you need to import the model. You need to import the models from TensorFlow, from TensorFlow dot Keras. You need to import this thing, these models. From TensorFlow.keras, import models, comma, layers. So these two you need to import it first. Then layers. Actually, in order to create neural network layer, each layer, we need these layers. And in order to initialize a model, we need these models. We need to import from TensorFlow.keras. So first I want to create a model. So what are the models that I imported from TensorFlow Keras? I'm using that models dot sequential. Actually, our models are sequential models. Our neural network model that we are creating using ML. How the layers will be? The layers will be sequential. Input layer, then hidden layer, then output layer. Like that, in sequence, our layers will be. So in this models dot sequential, we actually define how many layers that we want. Since we require 3 layers, one for input, one for output, and one for hidden layer, we are expected to create those in the form of a list. Like layers, right? We are creating. So for input layer, I want to create one. I just comment here. For input layer, I want, and I also require hidden layer, as well as I also require output layer. So let's create those 3 layers for building this model. While creating these layers, we need to remember 2 important points. One is what are different types of layers are there, and what are different activation functions are there. So I'll tell you in upcoming videos about these two concepts, that is what are the different layers and what are the different activation functions are there, when do we use what. So let's take a sample example like feed forward network. In order to create a feed forward network, we use dense layers. This is a type of layer. We use it to create just a feed forward network. Then while creating a layer, we need to specify how many units or how many neurons that we allocate. In input layer, I want totally 64 neurons to take the input. And then here we need to, since it's an input layer, we also need to specify one thing. Since we are creating it using a dense, or you can create it by using whatever another layer method is also there. By using that also you can create. So while creating any input layer, you need to provide input shape. That is, so whatever the training data that I want to provide, that is my input data. So that training data shape I want to take. So xtrain dot shape of 1. So first element is shape I am taking, and I am taking this data as a tuple. So that's why I provided comma here. So while creating any input layer, this parameter is important, input shape, that is that you need to provide here. And optionally, you also provide activation layer, activation function. So what does this activation function indicates? So what happens after taking the input, what you want to perform? So currently I'm taking ReLU. So it's one of the type of activation function. Basically, we use this function for creating non-linearity. So don't worry, in the next upcoming videos, I'll explain you about these activation functions in detail, about different activation functions, what are famous ones, and how to use them, when do you use them. So just remember, this is just introducing some non-linearity in the given input. This is nothing but the input layer that we considering or we specifying by providing some input shape. In the hidden layers, what we do is we just introduce some non-linearity. So the same layers dot this dense is used to represent just a feed forward network. Now here I want to put 32 neurons in this layer. So that's why I put 32 and activation function. I just want to put the same activation function, that is a ReLU, in order to introduce this non-linearity. Now, I want to use this model for classification. Like binary classification, I want to use this model. So for that, we have an activation layer, that is sigmoid. This sigmoid you can use for classification. So it acts the same like this logistic regression. So however, this logistic regression is classifying your text in the similar way. Here also your binary data will be classified. So here for output, I just expect to put only one neuron. So that's why I provided like this. Now I want to run this to check whether this model will build or not. If I get any errors, then it indicates we have done some mistake in middle. You can observe there is no errors. So we can say that we build this model successfully. So this is the way where you actually use to create your ML models with neural networks. For this, how you created your model? You just imported these models from tensorflow.keras and you created a sequential function. Then inside that function, you provided whatever the layers that you want to build. And currently for this demo, we are just using this dense in order to represent feed forward network. If we observe, here we provided the first number. This number indicates the number of units or number of neurons in that layer. Here, if we observe, in input layer, we have 3 neurons. In a hidden layer, we have multiple layers. This is the first hidden layer. This is the second hidden layer. This is the third hidden layer. But while writing the code, we considered only one hidden layer. We haven't created these two hidden layers. And in output here, you can see only one neuron is there. So based on the code that we return, our input layer contain totally 64 neurons, whereas a hidden layer, it's a single layer where it contains 32 neurons, whereas the output contain only one neuron. So like that, our ML model with neural networks will be created. And in order to represent input layer, we provided here input shape parameter. And in order to perform any task or active task, we provided some activation function here. We provided some ReLU here to introduce some non-linearity, and before providing the output, we are expecting some binary classification. So that's why we provided activation function here as sigmoid. It acts similar to logistic regression. If we implement a logistic regression without using neural networks, then we import that logistic regression directly from sklearn and we create our model with this method. Whereas since we are expecting to implement this logistic regression using neural networks, so that's why we introduced whatever the layers that we require and we provided the activation function in the output for binary classification. So this is all about how to build your ML model with neural networks. And in this video, you understood how ML model with a neural network is different from normal ML model. And you also understood how to build a ML model with neural networks. You also understood how to implement neural networks while building your ML model. This dense layer is nothing but it's just a feed forward layer. In ML, in neural networks, in TensorFlow.keras models layers, we have multiple layers that we can represent for other as well, other requirements as well. So this is about building your ML model with the neural networks. I hope you understood this video and you understood these concepts. If you feel this video is useful, then please like, share, subscribe, and hit the bell icon to get the latest updates. Thanks for watching again. See you back in the next video with another interesting topic. Until then, bye bye guys.